Hi guys, welcome back to my video and Jai Shri Ram to everyone. And today we're gonna discuss about rules of modulation techniques in the evolution of wireless communication from 1G to 5G. And introduction. The modulation techniques play a crucial role in the evolution of wireless communication from 1G to 5G. Here the modulation is nothing but a change in the carrier with respect to the message signal. The carrier signal will varies in accordance with the message signals. That is nothing but a modulation. Here the modulation refers to a process of encoding information onto a carrier signals for the transmission. And a different modulation technique we can see. At the right side we have different modulation types. And in that we have the analog and digital modulation. Analog is nothing but the signals which will be sent in the analog form. Analog means sine theta or cos wave or sine wave. These are including to the analog modulation. And digital means which is in the form of zeros and ones. And here in the analog modulation we have different kinds of modulation techniques. Here the amplitude modulation, frequency modulation and phase modulation. And in the digital modulation we have amplitude shift keying, frequency shift keying, phase shift keying, amplitude phase shift keying, and a quadrature amplitude quadrature amplitude modulation. And next, the rules of modulation in 1G and 2G. Here 1G is the first generation and 2G is the second generation. Here 1G is less network capacity and speed for the cell phones and compared to 2G. Here in 1G and 2G cellular system or modulation techniques like frequency shift keying and phase shift keying were commonly used. Here the frequency shift keying is nothing but we are changing the frequency of the carrier in accordance to the digital data. Your digital data is nothing but the message, and phase shift keying is nothing but the phase will vary in accordance with the message signal. Phase carrier will vary in accordance with the message or the digital data. And commonly we are used the frequency and phase shift keying in the 1G and 2G. Here FSK, frequency shift keying, allowed for the transmission of digital data and by shifting the frequency of the carrier signal between two predefined values. And phase shift keying enabled the encoding of digital data by shifting the phase of the carrier signal between different angles. And we can observe in the figure we have 1G, 2G, 3G, 4G. Here 1G is less capacity compared to 2G, and 2G is less capacity and speed compared to 3G. Like that it will follows up to the 4G. And 1G is 1G is the basic 1G is the basic of all 2G and 3G, 4G. And next we're gonna study the rules of modulation in 3G and 4G. Here, as wireless communication evolved to 3G and 5G, 4G, more advanced modulation techniques were introduced. Here, 3G is nothing but the third generation, and 4G is a fourth generation, which is higher than the 3G, higher capacity and higher speed. The 4G is, you already know, the 4G is having the higher capacity compared to 3G. And initially at the 90s all are using the 3G only. And quadrature phase shift keying, in this quadrature phase shift keying um, we have the m value 4. That m value is nothing but the 4 different phases and angles to encode multi bits for symbols. And 16 QAM is a quadrature amplitude modulation. Yeah, quadrature amplitude modulation is nothing but it will transmit which will transmit the signals or the information. It will convey the carrier and two message bits by changing or by modulating the carrier to the carrier signals. Here it is comes with the family of digital and related to the amplitude modulation. This quadrature amplitude modulation, which is namely of a family of digital modulation and related to the analog modulation. That is a common thing we can observe in the quadrature amplitude modulation. Next, we will study rules of modulation in a 4G and LTE. And LTE is then a long-term evolution. In the 4G era, we have the long-term evolution is in a fourth generation of wireless standard that provides which increase in network capacity and speed for the cell phones and the laptops and other cellular devices. It's compared to an 3G technology and OFDM devices that available frequency spectrum into a multi subcarriers, each carrier a smaller amount of data. By using multi subcarriers, OFDE improves spectral efficiency, mitigates multipath fading, and enables higher data rates. Here coming to the rule of modulation in 5G. Here 5G is a high efficient network we are using nowadays. Here the 5G, we know that what is the standard speed of the internet means 10 Mbps is a standard speed of the internet, and in the 5G we have maximum levels. Nowadays I'm also using the 5G era. In this 5G per second, it will consuming the 60 50 Mbps per second. It was taking that much of internet. The system was consuming. The 5G is a more dangerous compared to a 4G. Not a dangerous, more speed compared to a 4G. And your 5G network really heavily on advanced modulation. See, we can observe here heavily on advanced modulation technique to achieve their ambitious goals. Quadrature amplitude, we know that quadrature amplitude is used to transmit this information by using carriers or message signals by modulating and scheme and quadrature amplitude modulation schemes such as 256 QAM and 124 you know that 1 GB 124 QAM are being used to support higher data rates. A massive MIMO like multi output, not it is MIMO, MIMO, multi input and multi output. Here multi inputs are given and multi outputs are um, we are going to watch in the output, and combined with an adaptive modulation, adaptive modulation and beamforming are employed to maximize spectrum efficiency and enhanced coverage. And we can observe here what is the role of 5G era and modulation. Let come to the conclusion. And modulation technique have played a crucial role in the evolution of wireless communication. Yet the modulation, which is play a crucial role, we know that without modulation the wireless communications doesn't exist. And advancement advancements in the modulation having allowed for higher data rates, increased spectral efficiency, and improved system. And with the introduction of 5G modulation techniques like quadrature amplitude modulation and massive multi-input multi-output are at the forefront, enabling the realization of other visions for fast, more reliable, and latency sensitive wireless communications. And thank you for the watching, and do like my video.